All right, we have a quick integral here today from Caltech Math Meet 2024. A couple things to look out for on this one that jump out. We really don't want 1 over x inside the sign. We can have constants on sign, but like anything with exponents or where it's like 1 over x squared, sine square root of x, anything like that's a problem. So oftentimes what we're going to want is u substitution. And that's actually going to work pretty well with the x squared in the denominator. So what we'll do to start is we'll just do u equals 1 over x. It would probably work fine to solve for x, but let's just take a derivative here, and this is going to be du. Derivative of this is going to be minus 1 over x squared dx. So we basically have that, create a 1 right there, and then let's just multiply in a minus sign to make it work. So then like everything over to the right, that's going to be exactly this. And then so I don't change it, let's just multiply a minus out there. Go ahead and substitute, and let's just see what happens. So when I plug in infinity into that, that's going to be going to 0. You can do a little 0 plus to see that it's 0 on the right side. And then here we plug 2 over pi into here, and that's just going to be pi over 2. Then from here, like I said, all that stuff's du, so we end up with just du sine of u. We can go ahead and integrate, but first let's flip the bounds around with the minus sign. So we'll use that, get the larger value on top, like this. Go ahead and integrate, we get minus cosine of u evaluated from 0 to pi over 2. Plug in pi over 2, cosine of pi over 2 is just 0. So the first part is going to be a 0, minus, let me do this a little. I always try to be careful with this because I'll lose track of the signs. So you plug 0 and cosine of 0 is 1, so we have minus 1 there. Minus times minus is plus, and the answer on it is just going to be a 1. Okay, they must have known I was tired and they gave me an easy problem to let me off the hook on this one. So that's it for today. Thanks everyone for watching. Have a good day.